My name is Mr. Adebanjo, and I want to welcome you to today's teaching. And in today's teaching, we'll be talking about another theorem in circle geometry, and that will be the last theorem we are going to discuss on this circle geometry. And in the couple of videos we are going to make now, we'll be solving extensively on circle geometry using all the theorems that we have discussed so far. In this theorem now, we are going to make you talk about angle in alternate segments. Angle in alternate segment. When do we have segments in a circle? That's the question we need to ask ourselves. When do we have segments in a circle? Now, when you have a chord inside a circle now, segment is formed. When you have a chord drawn in a circle now, segment is formed. So you can see this line is a chord. So this space here you're having here that is colored is a segment. Also, this white one is also a segment. So when you have a chord inside the circle, that means a segment is formed. Also, if you look at what you're having here right now, you are seeing that this another chord here inside this circle. That means this side is also a segment, and this also a segment. And we have minor segment, we have major segment. This one here is the major segment because it's bigger than this other one. So look at the second one. This also is a minor segment because this one is smaller compared to this one. So this is major, this is minor. So having known what a segment is, that will help us to talk about the next theorem we're going to talk about. And that the theorem is talking about the angle in the alternate segment are equal. Angles in alternate segment are equal. Now, if you look at this line here, this line ECBD, this line here, we talked about this line in the last theorem we proved that this line is a line of tangent because it's touching the circumference of the circle at this point. So that means this line here, line ECD is a line ED is a tangent to this circle at point C here. So when you draw a line of tangent to a circle, as you can see, and you now draw a chord inside the circle, and the chord is touching the tangent at a point here. Now, this if you look at this line, this is a chord. Then that means this side, this point, this position here, this space here is a segment, and also everything you have here is also a segment. This is a minor segment here, and this is a major segment here. So if you have a line of tangent and a chord is drawn in the circle and it's touching that tangent, that means the angle that is formed here, the angle that is formed here in this segment is alternate to this angle here that is here. And look at how do we get this angle here. Look at this chord that is drawn here, and look at this another chord joined to it. This another chord joined to that this chord, and another chord joined to this chord here at this place as well. So where these two chord, this chord AB and this chord AC meet, that is joined to this chord you are talking about, that's where the angle will be. So you can see that this angle here is alternate to this angle. Also, this line here is also a chord. This line AC is a chord, and it's touching this tangent as well at the circumference here. So also that means this angle here, your angle here you can see on the screen now, is alternate to another angle. It's alternate to another angle. So you can see that this side also is a segment. So that means this portion also is everything here also is a segment as well. So since this chord here is touching this tangent here, so that means angle here is also alternate to this angle that is here. And that what we are going to see in the next and that what we are seeing here right now, that this chord here QX is alternate. The angle that is formed here with this tangent is alternate to this angle here as here, because if you look at the tangent, this chord here SQ here, and this is another chord uh, drawn to it, touching it, and another chord touching it. Where these two chords meet, that's where the angle is going to be. So that means this angle here is alternate to this angle, and that's why you're having that PQX is equal to SYQ. So you're going to be using this theorem to solve problem in the next in this video. Now, the first one you're solving is the one you are seeing on the board now. In the figure below, PQS is tangent to circle QRS. PQS, this line here is a tangent to this circle. Now, calculate SQS. SQX. That means this angle that is here. You have to calculate this angle that is here. So, and you can see this, since this is a chord, SD is a chord, and it's touching this tangent. That means there's an angle is formed here, and that angle will have a relationship with this angle that is here. This angle that is here and this angle here, they have relationship because this chord